When looking at two variables, you do sometimes want to know what is the correlation between them, and you can see it by looking at the scatter plot. However, there's a more accurate way of understanding the correlation and the strength of it, and that's using the correlation coefficient, or Pearson's products moment correlation coefficient. The correlation coefficient is a number, and we use R to represent the number, and it's a number from -1 to 1 inclusive. So the number could range anywhere on this timeline, and each number represents a different type of relationship and a different type of strength. So with 0, you have no correlation. So if your number is getting very close to 0 or exactly 0, it means that the two values have no correlation to each other, or the two data sets. The extreme values, you have the perfect negative and the perfect positive for -1 and 1. And then you can look at the intervals. So from 0.75 to 1, that's a strong positive correlation. Then you have a moderate correlation from 0.5 to 0.75, and then a weak positive, and then a very weak. We almost say that the very weak is a no correlation. If it's closer to 0 than it is to 0.25. And then we start in the negative. We have a strong negative, a moderate negative, a weak negative, and a very weak negative. So you can remember this timeline in order to understand and interpret the correlation coefficient. So if we look at this example, I have height and shoe size, and I need to know the correlation. I can roughly tell that the values, as the height increases, the shoe size increases, but it's better to take the correlation coefficient. We're also going to do a quick explanation on linear regression. So on your GDC calculator, you go to Stat, you go to Edit, you enter all the values in, and I've done that already. And then you go to Stat. Again, you click on Calc, and you go all the way to linear reg. Now, before you do that, you need to make sure that on your mode, when you click on mode, your stat diagnostic is on, so that you're able to see all the values. So again, we go to stat, calc, and then linear regression, ax plus b. This is preferably what we want to use. You put in what your first list and your second list is. The correlation won't the R value won't matter which one you put it in. The equation will matter, and we're going to discuss that in a second. So once you press on calculate, you'll get all of these values. Now the R value, it's not the R squared, it's the R value here, so 0.974. So I can say my correlation coefficient is 0.974. And looking back at the number line, I could tell that it's a strong positive correlation, so I can interpret it as a strong positive correlation. Then sometimes they ask you to find the equation for the linear regression, and that would be your a and b value. So a linear regression is a straight line, so you have y equals to ax plus b, which is the same thing as mx plus c. And they've already given you what a will be. It's 0.214 or 0.215, and the b is 2.9697. So you can write it all out. So that will be the a with the that's the coefficient of x, and then you have your b as all of them to 3 significant figures. So what this tells you is it helps you identify the relationship for, if you have the height, it will give you the shoe size. So this is the shoe size and this is the height. Now, if you wanted the opposite, you wanted an equation where you input the shoe size to give you the height, then when you set up your calculation for the linear regression, you switch the lists and you make L2 your x list and L1 your y list. And depending on what the question wants, depending on how you want to calculate the input and the output, this is what you have. Now, we use the linear regression because this is the best line of best fit that you could do on your scatter plot. So we usually do a rough line of best fit on our graph that goes through the mean, but this is a better equation that if I have my scatter plot, this line would just go through it. So it's a much better line to the most accurate one that the calculator can give you. Now, this is a bit extra if you want to do it, but if you want to plot it, then I can store my equation in here. So I could go to Fars and function, and I'm just going to press Y1 so that whatever linear regression I find, it's going to store it in Y1. And then I'm going to go to second stat plot, and I'm going to turn on my first stat, and I'm going to click on the first one, which is a scatter plot. And I'm going to put X as my L1 and Y as my L2. If I switched them, if initially my linear regression was switched, then I have to switch these as well. And then I can just graph it. And you can then check and calculate that this line of best fit actually goes through the mean, which is what we want, and it's the best line that goes through most of our points. So it's a good prediction for if you have a height, what shoe size someone would have.